Alrighty, here we go. The great news for you now is you get to grab your calculator and use that as your tool, okay? Because a lot of these equations are going to have nasty numbers. The thing that we're after, or the objective today, is not about your computation part. It's the process and the algebra about solving an equation. So make sure you've got your calculator. That's the first thing. And then get out your notes and away we go. Chapter 2, Section 7. Your learning target is pre-printed for you today. And basically it's going to say, I can solve equations with rational numbers. Now, here's the deal. We've talked a little bit about rational numbers, but haven't been diving in too deep yet. Basically, rational number means it's anything that can be written as a fraction. And I mean like a normal fraction, not weird fractions in fractions, decimals in fractions, a plain old good fraction. Fractions can be written as decimals as well. So what we have to watch out for is if it's written as a decimal, it's also probably rational. It has to be what we call a well-behaving decimal, meaning it either stops or it repeats. So we're going to talk a lot about those in the coming days as well. And let's make sure now that you look at your vocab and we talk about a few things. Inverse operations. Inverse operations are operations that undo each other. And I think the best way to illustrate this is to put the combinations together. So adding means you add some sort of value. Subtraction is its counterpart. They undo each other. Multiplying and division. Those are inverse operations. They undo each other. Eventually we'll get into things like squaring and square root. Those undo each other as well. But these are the main combos that we're going to talk about today. And we're going to use equations all the time. So I suppose we should just make sure you understand equations. What is it? Well, basically, it's kind of like looking at this from a language arts point of view. An equation is some sort of math sentence, and it has an equal sign in it. That's the big thing right there, okay? So what we're going to do is focus primarily on how do we solve these. We did a little bit of this in Chapter 1. So that what you're going to do is find the variable, that's the letter, and figure out, okay, which side is it? Aha. Once you find it, you work at getting that variable all by itself. Sometimes we use the word isolate. We want to isolate the variable. What that means is whatever operations that are happening to the variable, we want to undo them. So we're going to use these ideas of undoing or using an inverse operation. And then, for goodness sakes, check your answer, because we're going to have positives and negatives. You're going to have fractions and things, and good gracious, we definitely want to do that. So make sure you have your handy dandy calculator ready, okay? Because we're going to use this as a guide. Here's an equation. What I want you to get into the habit of is put like a balance bar or a balance beam line underneath the equal sign. Because here's what happens. Whatever we do inverse operation wise to get that variable by itself, we have to do on each side of the equation to keep things balanced. Can't just do it on one side and knock things all out of whack. Okay? Have you ever been on a teeter-totter and someone jumps off all of a sudden and wham, gets out of balance? Same idea here. So I'm finding the variable m, and right now I'm adding 4 6/10. So to undo this, I'm going to subtract 4 6/10 because this goes to 0. I want you to think of this as like positive and negative. Those go to 0. And m plus 0 is just m. Sweet. However, if I do that on the left-hand side, I have to do this over here, okay? Now, you feel free to use your calculator and crank this out, okay? I'm going to do it by hand because I'm old, and I can do some things this way faster than grabbing the calculator myself. I get 4 4/10. Check me. Is that what you got? Now, let's check to make sure that works. So go back to the original and plug 4 and 4/10 in. So when you grab your calculator, 4 and 4/10 plus 4 and 6/10, do you get exactly 9 or 9.0? Ta-da! Success. I'm going to get my calculator. Hold on. Just to make sure. Okay. Got mine right here. Okay. Just to help us out and keep us accurate. Okay. All right. Here's another one. More decimals. Okie dokie. M is my variable again. This time I'm subtracting 9.1. Oops. Put that bar in there. All right. So I want to add 9 and 1/10 because then these are opposites. They go to 0. And M plus 0 is M. Add 9M 1/10 here. Okay, now careful because that 3 is negative. So really this is like doing this problem here. Okay, you should, and double check me here with your calculator, get 6 and 1/10. Okay, check yourself. Okay, go through this process. I'm going to rewrite this here so I don't have that line through there because it makes it look like not equal. Go ahead and check it. Take 6 and 1/10 in for M and subtract 9 and 1/10. Do you get, what do you get? You should get -3. There you go. Okay. All right. How about this guy? 5.5. Oh, what's going on here? Multiplying. So in order to undo multiplying, I'm going to divide by 5 and 5/10. Now, why am I going to divide? Here's why. Any number divided by itself is 1. So 5.5 divided by 5.5 is 1. And 1 times b over 1 is just b. Woohoo! That's exactly what I want to do. But to be fair, I have to do the same thing over here. Okay, now in the olden days, we would do this by hand and divide. Okay, and then move the decimal point over, move the decimal point over. And then I'd start doing my division. Okay, I'm thinking to myself, I know that 5 goes into 75 about 15 times. So in my head, I'm thinking it's going to be close to 15. But let's go ahead and do this because I'll be honest, most grown-ups today grab a calculator just as fast as you do because it's built in right on their phone. I just know in my head this should be close to 15. When you do this, I get 13 and 8/10. That's close to 14, which is close to 15. So my answer makes sense, but take a moment to check it. For goodness sakes, you have the tool. My initial problem said take 5.5 times whatever b is. I'm saying b is 13 and 8/10. Okay, check it quick. Good grief, you have a handy dandy tool. Oh, look at that. 75 and 9/10. Works. All right, let's keep going. Fractions. Oh, quit whining. Fractions are our friends. Here's the deal. D is being divided by 4. We undo division, its inverse operation is multiply. So here's what I want you to do. Make a big fraction here, okay? Make a big fraction. And I want you to think of multiplying by 4, which is the same as 4 over 1, okay? We have to be fair and do that over here. Multiply by 4 over 1, okay? Because I have to do the same thing on each side. The beauty is that a 4 in the numerator can divide 4 in the denominator and give me exactly 1. And 1 times my variable d is d. Yes. 2 3/8 times 4. Well, if you want to do this by hand, you'd change this into an improper fraction, 19/8, and multiply it by 4 over 1. But you also have this handy dandy tool, okay? And if you want, I'm telling you, go ahead to save time on the computation. I know that if I'm taking 2 and a little more times 4, I should get 8 and then a little more. So in my head, I'm thinking maybe 9-ish, 8, 9, something like that. Let's go ahead and crank this out. Remember that on this particular calculator, which is the one that you will see on the Minnesota assessments in the spring, To get a mixed number, if you want to do that, press the second button up here and then the fraction button, which looks like n over d. Okay, so when I do that, I can plug in 2 and 3/8. Make sure you use your, gosh, how do I get over to, see, I can't even do this because I'm not so good at these silly fractions. Okay, plug it in your calculator and you should get, I bet it leaves it for you as an improper fraction, huh? Does it? Tell me. Okay, so I would get maybe, well, I could get 76 over 8, but I see that 4 in the numerator is a factor of 8 in the denominator, and I get 19/2, which is the same as 9 1/2. Sweet. Didn't I say around 8 or 9? There you go. All right, check it. So put 9 1/2 in and divide it by 4 and see if you end up with that original answer, and boom, it'll work. Checks, check, check, check. There you go. Now, for me, am I that picky? If you're using the tool, you can leave it as improper. I guess we could turn it back this way. I'll accept the decimal as well, but it'd be a good idea so that you have a grasp of about the value of your answer for the variable. Okay, fractions, fractions, fractions. Now, if we were doing these by hand, I'd say get the common denominator and all this good stuff. You want to get y by itself. We're going to undo subtraction with adding. These are exact opposites and they go to 0, and y plus 0 is y. Yay. Okay, so if we're doing this by hand, I'd turn this into sixths and add them up. I'm allowing you to speed you along to get your answer on a calculator, but you should get 5/6. Leave it as a fraction. Okay, check your answer. Take 5/6 minus 1/6. That was your original problem. And you'll get 4/6, which is the same as 2/3. Okay, let's keep going. Same thing here. Here's y. We're subtracting a fraction. Undo subtracting by adding. Do the same thing over here. These are exact opposites and go to 0. Take 3/4 plus 1/2. Go ahead and use a calculator if you want, but I know that this is going to push me over 1. This is the same as 2/4, so then when I add these, I get 5/4, which is the same as 1 1/4. Oh, for you decimal people, that's 1 25/100, but come on. Fractions are our friends. Ooh, okay. If I am looking at this, and if I didn't have a calculator, I'd be thinking, ugh. Do you notice in your notes it says something about the reciprocal? I'll explain why in just a moment. Think of this fraction as just a blob, the number. You're multiplying this number, even though it's a fraction, with x. And you undo multiplying by dividing, okay? So in the big picture, I'm thinking divide by 5/6, because any number divided by itself, except 0, gives you 1, okay? It's just that that's really ugly to look at this way. But just trust me, that's a 1x, okay? On this side, you have to do the same thing. But whoa, baby, this looks bizarre. And here's why we said think about the reciprocal. 5/8 divided by, instead of having this big, what we call a compound fraction, it looks like fractions in fractions. Think of this as dividing by 5/6. And then, oh yeah, division means multiply by the reciprocal. Ta-da! That first number stays the same. Division is multiplied by the reciprocal. Aha! Now, you could get 30 over 40, but I would rather do some simplifying here, numerator and denominator wise, and I get 3/4. If you used your calculator, you get that, okay? Check your answer. Plug it in. Now, some of you, if we were doing this by hand, and once you get more into algebra and I say, yeah, if you had this 5/6 x equals 5/8, Instead of thinking of this as dividing by this fraction, you could just jump right into reciprocal land and say multiply by 6/5 because all of this goes to 1 when you multiply reciprocals together, and you get the same answer. But if that's just like blowing your mind, just keep working with me here, okay? 3/8 times x. I'm multiplying. 3/8 is just a number. It's a number times x, so I'm going to divide by that number to get the variable alone, okay? Yes, it looks awkward having this big old compound fraction, but 3/8 divided by 3/8 is 1. On this side, you also have to take 6/19 divided by 3/8. Think about what that looks like. Dividing by a fraction means multiply by the reciprocal. Yeah. If you're doing this on a calculator, it will automatically give it to you in simplest form, but I'm old, so I'm going to do it by hand. I don't want to do 19 times 3. I mean, I know it's 57, but why? Why do it if I don't have to? Because I can simplify a little bit. I get 16 in the numerator, 19 in the denominator. That's in simplest form. That is kind of a gross answer, but you have a tool to go ahead and check it. Go ahead on your calculator and check 3/8 times 16/19. Or, for goodness sakes, this one I can do by hand. 8 fits into 16 twice. I get 6/19. Oh, look at that. It's so beautiful. Almost makes me cry. Yes. That's it. Hot diggity. Your job is to go into your purple packet, find pages 17 and 18. I only want you to do the odds. You are allowed to use a calculator. Yes, sirree, Bob. But here's the trade-off. Using the calculator means you have to show me your work. So I expect to see what you're doing on your calculator to help your calculations. Okie dokie. Show your work. Good luck, and may the force be with you.